Hello everyone, this video is about complex number loci. The first type of locus is circle. Circle center origin or 0, 0. So in coordinate geometry we know that in xy axis we have x squared plus y squared equals r squared. Now in complex numbers, exactly the same, but we use real and imaginary axes, and let's use a and b for the real part, imaginary part. So a squared plus b squared equals r squared. Now the complex number z equals a plus bi means the modulus is the square root of a squared plus b squared, and the modulus of z squared is a squared plus b squared, which means the modulus of z is r. So when you have this kind of equation, the modulus of z equals something, so this means we have a circle. If it's just equal sign, we have the circumference only, smaller than, equal, the area plus the circumference, just smaller than, area only, excluding the circumference. For example, sketch the locus of points representing complex numbers z satisfying the equation the modulus of z equals 7. So this means we have a circle, the center is the origin, the radius is 7. So that's the locus. Next type, center PQ. So this is in coordinate geometry. Now in complex numbers we use a, b, so almost exactly the same, but just replace the x and the y. And for the complex equation here, the complex number equation in z, the a plus bi is like a random point on the circle, so it could be anywhere here. The z1 in this case is the center of the circle, which is p plus qi. Z minus z1 would be a minus p, b minus q. This is z minus z1. The modulus of z minus z1 is just like this. So the modulus of z minus z1 is the radius. So if you have this kind of equations here, the modulus of z minus z1, this is a circle, the center is z1. Smaller than means we include the area. For example, z minus 3 minus 4i. So remember that we need z minus z1, we need to find the z1. This is the same as z minus 3 plus 4i. So the center is 3 plus 4i, or 3, 4, and the radius is 5. Alright. Next type, half lines. So if we have this locus, the argument of z equals theta. The theta is an angle, for example pi over 4. So this is the locus. So it's called a half line, not full line or just line, because usually a line goes in both directions, to the top right here and to the bottom left forever. But for a half line, we start from a point and then we go to only one direction. So it goes on forever in this direction, but it doesn't go to the bottom left direction here. So we start here. So this is actually, the z here is actually from z minus origin, z minus 0. So this is from origin to z. The z can be anywhere here on this line to the top right. And if we have the argument of z minus z1, almost exactly the same as this, but if the starting point is the origin, we use just z because z minus 0. If the starting point is another complex number or point on the plane, this is from z1 to z, so this is the starting point. And if it's z1 minus z, So that means from Z to Z1, the Z here would be the starting point to the Z1. And yeah, the angle is theta. So in this case, it's in the this direction. Okay. So for example, Z minus 2. So 2 is the same as 2 plus 0i, which means the starting point is 2, 0, which is here on the real axis. So starting this point, and the direction is pi over 3 from a positive real axis. And the last type is called the perpendicular bisector. So if we have a point or complex number point here, z1, z2, the perpendicular bisector means perpendicular, right angle 90 degrees, and bisecting, same length. The z can be any point on the perpendicular bisector line here. The equation is z minus z1, which means the distance from this z to this point is the same as the distance from z to this point. Z minus z1, z minus z2, modulus modulus, perpendicular bisector. So if we have equal sign, inequality like this, so this means not only when it's on the line, we also use all the area, because this is smaller than, we use the area the closer to z1, which means we shade the part including the z1 towards the z1. Okay, so from this line towards the z1, so towards the one with the smaller sign here, the one on the smaller side. And if we don't have equal sign, we don't use the line. For example, z minus 2 minus 6i equals z plus 4. So we need z minus z1, z minus z2 form to find the points. This is 2 plus 6i and minus 4 plus 0i. So 2 plus 6i means 2, 6 around here. Minus 4, 0 is here. So in the middle, we have the midpoint, and we have the line which is perpendicular through the midpoint. So the sketch would be like this. Alright, I'll see you again next time.